Okay, so we're gonna start by doing the absolute value equations. I just did the two that were like kind of a little bit more complicated, the absolute value and the quadratic. So with the absolute value, remember you've got to first get the absolute value on the side by itself. So I'm gonna divide both sides by -2 here, and it's gonna flip my sign. So it becomes less than 5. And then it becomes, this is a less than, which means an and statement. -5 is less than x minus 5, which is less than 5. Add the 5 in all three places. 0 is less than x, which is less than 10. So on my number line, it would go from 0 to 10. I'd get a parentheses on 0, parentheses on 10, shading in between. Questions on that one? So this is the one you are going to have to shade on your answer sheet. I'm going to have to look at your answer sheet for your graph. You're going to solve it and then give me the graphed inequality answer. Okay, this says solve the equation. So this is my quadratic with inequality. I got to get everything to one side because I have an x and an x squared. So I get x squared minus 5x minus 6 is greater than 0. This would be x minus 6 and x plus 1. And then I treat them as though it's equal to 0, and I get 6 and -1. Then I set up my number line, -1, 6. I plug in something that is less than -1, like -2. Something in between -1 and 6, like 0, and greater than 6, like 7. And I plug it back in either here or here, however you want to do that. Okay, so if I grab the first one, I can say -2 squared minus 5 times -2 is greater than 6. I can say 0 squared minus 5 times 0 is greater than 6. And I can say 7 squared minus 5 times 7 is greater than 6. So 4 plus 10 is greater than 6, and 14 is greater than 6. So that area works. 0 is greater than 6 does not work, so I rule out that middle area. 49 minus 35 greater than 6. And 14 is greater than 6, so I keep that section. So my solution is that x is less than -1 or x is greater than 6. And my number line, -1 to 6, would have a parentheses on the -1 pointing left and a parentheses on the positive 6 pointing right. So just be really careful, make sure I can tell the difference between your parentheses and your brackets when it comes to that graphing on the number line. Questions on those? All right, so that was the P2. Obviously, there was more of the graphing. I'm going to have the inequalities and that kind of stuff, but I figured those two were the ones that are, of them, the hardest, so I would go back over those. Okay, so P4, we've only got about 6 minutes, so I'm going to go kind of just through the concepts, and then I'll go back and work out the examples later. So this is graphs of equations. I skipped P3, which was literally plotting points, and then doing a scatter plot, which we did at the very beginning of the year. But the plotting of the points is like literally plotting your x and y points. I think we're good on that stuff. But this is P4, which is graphs of equations. So through here, we talk about how do you know a point is on the graph. If a point's on the graph, then when it's plugged in, the result would be a balanced equation. So we would literally take any kind of points and just plug them in, and if it works, then it's yes, and if it doesn't, then it's no. Sorry, hang on just a second. Okay, so I'll work out this example, but if it said something like this, determine if 1, 5 is a solution to y equals 4 minus absolute value of x plus 2, we're just going to take this and plug it into the x and this plug it into the y. If it's a true statement, then it's a yes, and if it's a false statement, then it's a no. Easy as that. All right, so if I plug 5 in for y and 1 in for x, I get 5 equals 4 minus the absolute value of 1 minus 2, which is -1. Absolute value of -1 is +1, and I get 5 equals 4 minus 1, which is 3. This is not true, so this would not be a solution. Obviously, if it equals, it is, and if it's not, then it's a no. Then we get intercepts. So again, something we've done a lot this year, but just to review it real quick because it's super important. X-intercepts are, to find them algebraically, we're going to plug 0 in for y. Y-intercepts, we're going to plug 0 in for x. If you're looking for it from the graph, the x-intercept is where the graph crosses the x-axis. And if you're looking for the graph on the y, it's where the graph crosses the y-axis. And there's no rule about how many of these can have, right? If it's a single line, obviously there's a limit to how many it can have, but it can have one or it can have none. But if it's a parabola, it can have 2 of one of these. If it's a, a rational function that goes up and down, there's no limit to them. The x-intercepts are also called zeros, if you remember that, or solutions. Okay, all of those, or roots, I think, was the other word we used. All of those are the same. They are. It was 8 to 820. So when we look at an example of that, this one says find the intercepts from the graph and algebraically. So from the graph, I would literally just figure these points are both -2 and +2. So my x-intercepts are at -2, 0, and 2, 0. And then for the y-intercept, it's here. We're jumping by 4s here. So 4, 8, 12. This would be 16. So the y-intercept would be 0, 16. And then to do it algebraically, we take our equation, y equals 16 minus 4x squared. To find the x-intercept, we're going to plug 0 in for y. We can actually factor this difference 2 squares. 4 plus 2x, 4 minus 2x. Or you could have moved the 16. You could have moved the 16 to the other side, divided by -4, done that whole process. And then from here, I could set these each equal to 0. I'd get -4 equals 2x. -2x equals -4. Divide both sides by 2, and I get -2. Divide both sides by 2, and -2, and I get +2. So that matches that. And then for the x-intercept, we would plug 0 in for the y-intercept. Sorry, that is the x-intercept. For the y-intercept, we would plug 0 in for x, and I'd get y equals 16, and that matches that one. So just make sure you know how to do both ways. I'm pretty sure on the test it just is the algebraic way, not the graph one. So just make sure you know how to do those. And the last thing to review in this section is symmetry. So this is a test for symmetry. If you look at the graph, remember, if you can fold it left to right, that's your vertical symmetry. That's your horizontal symmetry. If you can fold it top to bottom, that's your x-axis symmetry. And then if you can fold it both, it's your origin. But you're going to do this from an equation. So when you're looking for x-axis symmetry, you're going to plug -y for y. For y-axis symmetry, you're going to plug -x in for x. And for the origin, you're going to do both -x and -y. You're going to simplify it. And then if your equation goes back to the original form, or each term is the exact opposite, then the test is symmetric. Then it's symmetric to whatever that test is. So if you were testing the x and it works, it's symmetric to the x. Testing the y and it works, symmetric to y, and same for origin. Friday. And those questions look like these. So it'll say test for symmetry, or determine if the equation is symmetric to whichever one it is. So if I want to find x-axis symmetry, for the first one, I'm going to plug in -y. And -y squared becomes +y squared, and it goes back to the original, which means x-axis is a yes. Y-axis, I plug 0. I'm a -x in for x. And I get -x minus y squared equals 0. It doesn't equal the original, and only one term is the opposite, not 2. So it's not y-axis symmetry. And then we do the origin. -x minus -y equals 0, and I get -x minus y squared. Again, the x changes, not the y, so it's not symmetric to the origin. So this is only symmetric to the x-axis. And the last one, I'm going to do the same thing, x-axis symmetry, change the y. This time only the y changes, so that's a no. Y-axis, change the x. Both of them are even exponents, so it has them go back to the original. This is a yes. And then we know if we change both, the y is going to change, but the x's go back. So that's also a no. So this has just y-axis. So you can have x with origin, you can have y with origin. If you have both x and y, you're going to have origin, if you want to keep that stuff in mind. All right. Oh, that was good timing. Questions for me?